So find the number of functions by mapping this set onto itself such that after pi to the 6th of a is still a. Well, that means either pi of a is a for some elements. You can also have pi of a is a. Or pi of a is a. Or pi is a. So these are the factors of 6. Because why can't you have, let's say, pi to the 4 is a? Well, if one cycle of 4 gets you back to a, then a cycle of 6, because 4 is not a factor of 6, you're not getting back to a in 6 after 6 operations. So these correspond to subsets. Subsets of elements and each form a cycle. For example, if you take pi of a is a, that means you have 3 elements. Let's say the elements are 1, 2, and 3. Okay, so for example, this just means that 1 goes to 2, 2 goes to 3, and 3 goes to 1. That's one of the ways to do the cycle. And then after that, all 3 of these elements satisfy the original condition. Now, what if, let's say, f of 4 is one of these 3? Well, you're not getting back to 4 because you're stuck in this cycle after you reach it. So that suggests the subsets cannot be overlapping. Okay. And then the subsets need to have size 1, 2, 3, or all 6 as one whole subset. We can split this into cases, right? So you're trying to split 6 numbers into subsets where each subset corresponds to one or more cycles using the numbers in those subsets. So 6, 3, 3, 3, 2, 1, 3, 1, 1, 1, 2, 2, 2, 2, 2, 1, 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So let's get the easy ones out of the way. This is one way. And actually, we can just go backwards. So for this case, you need a cycle of 2. So 6 choose 2 ways. And then what these ones represent is just a subset with one element, meaning the element just goes back to itself, right? So pi of 1 is 1, essentially. So for this, there's 6 choose 2 ways. And once you have a cycle of 2, like so, then 1 has to go to 2 and 2 has to go to 1. So once you have a cycle of 2, the ordering in that subset, within the subset, is fixed. So this is 6 choose 2 times, here I'll just use this, 6 choose 2, 15. 2, 2, 1, 1. Six choose 2, 4 choose 2 over 2 factorial to avoid double counting. And then after that, the arrangement is fixed. So 45. This 6 choose 2, 4 choose 2, 2 choose 2, all over 3 factorial to avoid triple counting. So that is 15 ways. 3, 1, 1, 1. For a cycle of 3, say it's 1, 2, 3, you can either have 1 goes to 2 or 1 goes to 3, and then the rest are fixed, because 2 cannot go back to 1, or else it becomes a subset of 2, not 3. So 6 choose 3 times 2 is 40. This case, 6 choose 3, 3 choose 2 times 2 for the subset of 3. Everything else is fixed, 120. 6 choose 3, 3 choose 3 over 2 factorial. Each times 2 is 40. And finally for 6, 1 can go to either 2, 3, 4, 5, or 6. Let's say it goes to 2. 2 cannot go back to 1, so it has 4 ways. 3, let's say it goes to 3, then 3 can only go 3 ways. And then the next number can only go 2 ways, and it's 5 factorial. So these are the numbers. You have to add these, and we're done. If you add, you get 396. So that's the answer. Yay.